Today we're going to move on to geometric sequences, and the first thing you need to know about a geometric sequence is that it has what we call a common ratio, and we call that the letter R. Now, geometric sequences, if you remember from the start, are ones that you multiply by a certain value, which is R, and then that generates the numbers in the sequence. And R cannot be zero, but it can be negative, positive, or fractions or decimals. So an example would be the sequence 1, 2, 4, 8, 16, 32. Now to get from one term to the next, we are doubling each time, so R would be 2 because we are multiplying by 2. Another one we could have could start with 100 and then go 50, 25, 12.5, etc. Now this one, it's halving each time, so we would say that R is 1/2. Okay. And then you could also have, like I said, negative ones. So maybe you had like 1, -3, 27. I forgot. Not 27. If this one was timesing by -3, we'd then get 9. Then we get -27, etc. So this one, each term, to get from 1 to -3, we multiply by -3. Times -3 gives you 9, times -3 gives you -27, etc. So that would be R equals -3. And then in general then, what is happening is you have first term A, and then the next term would be A times R, so AR. Then the next term, you'd be multiplying this one by R, so you actually end up with AR times R, which is AR squared. And then for the next one, you times it by R again. So it would just continue like that. So in terms of an nth term, we always have one less R than the number of terms we've got. So for example, this one is the 5th term, 1, 2, 3, 4, 5, but you only have the A multiplied by 4 R's, so one less. So in general, it's AR to the n minus 1. And that is what U of n would equal. Okay, so that's how you get the general term of the sequence. Okay, and you need to know that this formula, UN equals AR to the n, take away 1. That one's important. You need to learn that. Okay, so I've written down the examples today, so you might want to pause the video in between so you can copy them down and then do them with me. So, first example says for the geometric sequence 324 minus 108, 36 minus 12, A, find the formula for the nth term, so that's like this, and then hence find the 10th term of the sequence. So for part A, we can just use this formula here, but we need to figure out what A and R is. Now A, I can see, is the first term of the sequence. And then to get R, what I can do, because I know that 324 times something would equal the next term, minus 108, if I divide the second term by the first term, it will give me R. So if I do minus 108 divided by 324, use your calculator, we get -1/3. So the common ratio on this sequence is we're timesing by -1/3 each time. So if I then use the nth term formula, UN would be A, so 324 times R, which I'm going to put in brackets because it's negative, to the n minus 1. And then for part B, to find the 10th term, we can now just use this formula. So U10 would be 324 times -1/3 to the 10 take away 1. So this power here would be 9. And then again, you can just put it in your calculator, and I would definitely put the minus a third in brackets and then do that all to the power of 9. You can see that. There you go. So I get minus 4 over 243. Okay, number 2. Again, remember you can pause so you can see, write down the examples first. Try to highlight them for you so you can see them clearly. Okay, so number 2 says the 7th term of a geometric sequence is 13. So I'm just going to highlight that. And then the 9th term is 52. Find the possible values, so there could be more than one, of the common ratio. Well, these questions are really common. Because they give you 2 different types of information, we're going to end up creating simultaneous equations. So for the first one, if the 7th term is 13, well, I could write down that 13 would equal AR to the 6. Because remember, for the 7th term, you'd have 1 less R. And then for the other one, the 9th term is 52, so 52 equals AR to the 8, because it's 1 less again. And then what you could often do with these ones is you can use simultaneous equations, but you can do a method where if you look at the 2 equations and you find the one with the highest power of R, we can call this one 1 and this one 2. What we're going to do is we're going to do the highest value of R1 divided by the second. So what that means is I have 52 over 13 on this side because I've done 1 divided by 2. And then on the other side I have AR to the 8 over AR to the 6. And this works well because the A's will cancel, and then 52 divided by 13 will give us 4. So I actually end up with 4 equals, and then if we take away powers here of R, 8 take away 6 is 2. So R squared now equals 4. And then so if we square root 4 to get R, remember that you could have 2 values, it could be a positive or negative 2. So those are the 2 values that R could be. If you didn't want to do it that way, what you could also do as an alternative is you could make A the subject of both and then put them equal to each other. That will work exactly the same, so I can show you that as well. Just do a little side working here. So if we made A the subject of both of them, I'd have 13 over R6 equals A and 52 over R8 equals A. If they both equal A, I can put these equal to each other. And then you can do some cross multiplication here. So I can actually times up the R8 and then divide by the 13. And here again you'll have R8 over R6, so that's R squared. So we end up with the same as last time. But I think a little bit more working out with that way. So that's just the alternative way. Okay, then number 3. This time we've got 3 consecutive terms of a geometric sequence with common ratio which doesn't equal 0 are x minus 2, x add 2 and 5x minus 2. So we don't know where in the sequence these are, but we know these are next to each other. Find the possible values of x, and then for each value of x, find the common ratio of the sequence. So what we can do with this one is we know that the common ratio must be the same to get from x minus 2 to x plus 2 as x plus 2 to 5x minus 2. And if you remember to the first example we did, to get the common ratio you can always divide the second term by the one in front of it. Okay, so x plus 2 divided by x minus 2 must be r, and that would be the same as if you did the third value here divided by the second. That would still give you r. So 5x minus 2 over x plus 2. And then this becomes more of an algebraic problem to solve. So I'm going to do some cross multiplication. So I'm going to have x plus 2 times x plus 2 on this side, and then 5x minus 2 times x minus 2 here. Then you want to expand both brackets. Okay. And then rearrange to make it a quadratic on one side. So since I've got the 5x squared here, I'm going to take away all of these onto this side. So I end up with 4x squared minus 16x, and that'll be it actually, because the 4's will cancel each other out. So I could factorise this now, because they both have a common factor of 4x. So that gives me two values of x. For this one to be true, x would be 0, and for this bracket to be true, for the equation, x could be 4. Now for part B, it says for each value of x, find the common ratio of the sequence. Well, what we could do there is we could start generating some terms, or we could use what we've already done here. So we know that the common ratio would be x plus 2 divided by x minus 2. When x is 0, that would be 0 plus 2 divided by 0 minus 2, if I'm using these ones here, which would be 2 divided by minus 2, which is negative 1. And then if I do it when x is 4, 4 add 2 divided by 4 minus 2, which is 6 over 2, which is 3. So r equals minus 1, or r equals 3. Another way you could do it is you could put the values of x into the three terms and then just look at the sequences, see if you can spot the pattern. Okay, one more then to go. So this one, number 4, says we have a geometric sequence which has first term 10, 10 there, and common ratio a third. What is the term number of the first term that is less than, 10 to the power of minus 6? So what we're trying to find in this one is when is the term, so un, smaller than 10 to the minus 6. And what I know already is a is 10, because they've told us that, and r is 1/3. So I can swap now un for the nth term formula that we wrote down at the beginning. So that's a times r to the n minus 1. Okay, so the first thing I could do here is I want to find n, and it's at power at the minute, which is making me think that we're going to have to use logs. But I've got this times 10 here, so I'm going to divide both sides by 10. So that just makes this 10 times smaller, so 10 to the minus 7. And then what we can do is take logs of both sides. So log of a third n minus 1 is less than log 10 minus 7. If you remember from your log rules that when you have this situation, you can bring the power down to the front. So n take away 1 times log of a third is less than log 10 to the minus 7. And we're trying to make n the subject, remember? So it would be good now to divide through by log of a third. Now you have to be really careful when you're dividing by the logs, because you don't actually know what value it is, and if it is a negative value, it's going to change our inequality sign, because if we divide or times through by something negative, it always switches the signs. So I'm just going to check on the calculator what log of a third is, and it is negative. Okay, so that means that we are going to have to change the sign. So when I write this out now, n take away 1, I have to swap it to greater than log 10 to the minus 7 over log of a third. So n, therefore, we just need to add 1, would be log 10 to the minus 7 divided by log third, add 1, and we can now figure this out on the calculator. So log 10 to the power of minus 7 divided by log third, and then add 1. I've got 15.67132292. So just write that down, 15. And for these questions, n needs to be a whole number because n is the number of terms. So if n has to be greater than that, we can say n must be 16. So when n is 16, it'll be the first term that is less than 10 to the minus 6. Okay, so you should now be able to have a go at exercise 4E. I will do another video in a minute of the red questions for you.